Not necessarily, but I mean, there will be an opportunity later, but it's not like necessary. So, are these like timed? Okay. All right, I guess we'll get started. So this is what can wiki functions and abstract Wikipedia do for you? Okay, slide is missing. So my name is Corey Massaro. I work on the abstract Wikipedia team. And the point of this talk is to partly raise awareness and partly learn for my edification and for the health of the project what would be useful, and also inform you all how to use these projects. So the question was just asked, is a laptop needed? It's not needed. It can be helpful if you want to follow along. If we do the live coding, it kind of depends on how far we get with that. As we know, tech demos are always a bad idea unless you pre-record them. This is not pre-recorded, so it will be the most fate-tempting tech demo possible if we actually do it. But first I want to explain the project. So, Abstract Wikipedia. Abstract Wikipedia has the goal of generating content using Wikidata, and for that content to be available in any language. So the motivating kind of statistic here is if you look at Wikipedia, there are about 20 million different topics, as in there are about 20 million distinct articles. How you get to that number is of course hazy, but that's, you know, the right order of magnitude. And there are about 300 language editions of Wikipedia. So if you really don't like slideshows, so if you multiply that, you get 6 billion. So that's sort of 6 billion units of effort needed if you wanted to represent all of the knowledge that exists in Wikipedia in every language. So as an example, we have here Thessaloniki, and we have a bunch of different facts about Thessaloniki. So one would be that it is the second largest city in Greece. We have here the same thing in Greek, and then the same thing in Persian. So Dovamin Shahre Bozorg Dar Yunan, that's the same fact, the second largest city in Greece. Thessaloniki is pretty well covered, relatively speaking. It has pages in 129 Wikipedia editions. That's, you know, a good amount, but it's still not even half of all Wikipedia editions. If you look at other things, like other cities in Greece, you have Veria, which only has pages in 11 different languages. So we know this. Coverage kind of differs among language editions. So the kind of motivating intuition is that if you could, instead of requiring that effort of representing the same fact be duplicated in every language, sorry, I don't know how to work with slideshows. No timings. Let's turn that off. Maybe that'll work. Nope. Okay, I'm just making it worse. Let's just, whatever. I don't use Windows and I don't know how to use slideshows, but that's okay. We're gonna keep going. Now it's just going faster. Does somebody know how to do how to handle this? Because I do not. Yeah, but it's like changing automatically. Yeah, that's the problem. And now it won't go to full screen. Do it, do it. Nope. Let's do that. Nope, that's going to take forever. Is it this one? Just like, I have no idea what's. I just want it to not change slides automatically. thought it was the timings, but yeah, maybe. Okay. Okay, whatever, I'll just thank you. Okay, sorry about that. Thank you. Okay, so that's where we are. Okay, so if we could deduplicate that effort, right? So if we could imagine you make the effort one time to represent any given article, and then you kind of work on the linguistic scaffolding apart for each of the 300 languages, you could sort of deduplicate that 6 billion units of effort down to 20 million. So in order to do that, you would use something like natural language generation. That's what Abstract Wikipedia proposes. Abstract Wikipedia proposes a community-led natural language generation effort, and community-led sort of from the ground up. So you would start with facts and linguistic data that come from Wikidata. Then you would use some functions that are also built in a community-led way in order to generate strings of text in any language you want. So how do you run those functions? That's where this sibling project of Abstract Wikipedia comes in, of wiki functions. I feel like it's like proximity based, or like if I breathe wrong, it changes. I don't know how that works. Okay, so wiki functions. Wiki functions is a functional and fully internationalizable programming language. So what that means is instead of writing a single piece of source code, I can write a function and I can be editing it in English. And if you want to access that same function, you can edit it in Spanish, you can edit it in Turkish, whatever language you want, as long as somebody has gone in and built the labels for it. So this is something that really doesn't exist anywhere else. The idea that the same piece of source code can be fully internationalized. It's also integrated with Wikidata, so there are already facilities for acquiring the facts and the linguistic data and things like that from Wikidata. And for more heavyweight stuff, if you want to, the functions themselves in wiki functions are really good and descriptive, but if you want to write, a really heavyweight piece of code, you can also drop into Python or JavaScript, and we're adding support for other languages too. So it's kind of a hybrid programming language situation. And with that, you can start embedding functions into other wikis. So currently, Wiki Functions itself is live on, I think as of yesterday, 123 Wiktionaries. We were at 119. The numerology of this is strange. We're also live on 5 Wikipedia editions, as well as a bunch of other smaller wikis where, people think it's okay for us to run functions, which is not necessarily the most, always the safest thing to do, you'll see why. But here's a little demo of that, and this is a very fun page, but please don't, don't spam it. So this just looks like text, but if I go in and edit it, you can see this syntax here. So, oh, that's really pixelated up there, huh? Okay, so that says function, and then this kind of, oh yeah, I can zoom in. Yeah, okay, thank you, good. Is that better? Is that more visible? Okay. Sorry? It's fine like this. I mean, they're pretty narrow, but yeah, we can get a little bigger. So, oh, there we go. That's even better. So this is a function. These IDs are sort of the unlabeled form. So these are just unique IDs that are assigned to every object that gets built on wiki functions. And then this is an argument. So these are like the inputs to the function. So this Z10018, this, I happen to know, is the function to capitalize a piece of text. So you saw before it said, like, this is a bit shouty. So if I go in and edit the source code, many thanks to my colleagues on the team for building this, but like we can say, hello, and we do a bad thing, and we just say, no, important is a very good, important edit. And this is going to take a little while. It's going to say function is being called, but I promise we are actually running a function right now, and it's going to make some output. But the other interesting things we can see here are, for example, this is a date, and this is just some text, but the community has actually built the function that says, okay, take this text representation and turn it into an object, a date object. And that date object can then be viewed, manipulated in any language you want. So we have labels for date in a bunch of different human languages. So this is sort of the basics of the platform. We'll come back to that later. It kind of takes a while. Guess what we're working on right now on the team? Making the functions take less time to run. So this is already kind of useful, right? So you can see, like, if you can take dates, you can take numbers, you can do interesting stuff. So like, let's say you wanted on a Wikipedia page to have a temperature display in Celsius automatically. For some people, and Fahrenheit for others. I guess people only in the US, and where else still uses Fahrenheit? But you know, if that's something people wanted, you could just do that automatically. And then nobody would have to, you know, memorize conversions. Ages, this is really cool for if you want content to update automatically because people have birthdays, so you don't have to go through and, although I understand that that is very fun to be the first one to edit a person's age, you could save yourself some effort by not doing that. So other applications, I really don't know what makes the slides change. It's like a timer, but also a proximity sensor. I don't know. So, okay, apologies. I don't mean to pick on Persian. This is just an example I really like because I found it. So I was looking in 2021 at the Wikipedia article for Ecuador, and I saw that the president was out of date. So, Lenin Moreno. This was wrong. This was wrong because Ecuador just had an election. And I went, well, surely somebody will get to it. And nobody got to it for like 3 years, and I don't speak Persian natively, so I was like, it's not my place. So I just watched. And then the president had like a really bad scandal and got removed from office, and I guess that news cycle got picked up. So somebody was like, oh, I guess I'll change it to the president, who's now not going to be the president because of his scandal. So then it was swiftly changed again. So that was really fun, but you could see that like for 3 years, this was out of date. So this is, you can see that this is inside of a template box. So templates generally solve this problem. But there's kind of a maintenance burden there too, because for a template, you have to copy it among all the different languages where you want to use it. So you could, if you wanted, instead write a single wiki function. So Wikidata has a concept of relations. So for a country, there's a relation that's called head of state. Thank you, slides. It's called head of state. So you could just say, for given country and given language, go retrieve the head of state, and if the head of state has a label in my language, then boom, I just have it. And then that stays as up to date as Wikidata is, which is, you know, usually pretty good. In this case, the Wikidata item for Ecuador's head of state was more up to date than the Persian language Wikipedia. If you wanted to run this inside a template, I think that would also be possible. So here's another example of stuff that can currently be done. A lot of Wiktionaries, which is most of our current deployment targets, do things like tell you morphological information. So here's the declension for a Latin noun. It's the noun for farmer. This exists in Spanish. This exists in Greek. This happens not to exist in Uzbek. So if we wanted to, we could just write a function that generated this, had a couple of labels, so like, you know, onomastiki, nominative case, you can get that from lexical data in Wikidata, and then you can just, boom, label it. This actually exists. This function does that. You can kind of see that, right? I'm not going to try to magnify this. I don't know what the slides will do to me if I try. But I promise you, this is generating an HTML table to display the thing I was just talking about. Let's take a function is being called. So this is probably just because I haven't refreshed. Let's see. Nope, not because I'm refreshing. It is because it's being slow. This is why. Oh, yes. Okay, it worked. I promise it's not always this miraculous, like our functions do work. But yeah, but you can see like this is embedded on a wiki page, and we were able to generate this kind of text. So, and any of these things we could also, we could change, we could say tomorrow will be whatever. Actually, we did just change this one too. So this is true, I think. Yes, that is still true. Today is the 26th. So this one is actually being calculated from the current date. So okay, hopefully you're convinced that these things work when they're embedded in a wiki. Okay, here begin the slides that I cannibalized from the last talk, so I apologize. This is a city in Kenya, because Wikimedia was in Kenya, but okay, you'll forgive me that I didn't update these. Here's another example of kind of almost stub-like content. So this is a city in Kenya, and in 3 languages, Turkish, English, and Spanish, and they all mostly have the same pieces of information, although you'll notice that the census information differs. So Turkish uses the 2009 census, English uses 2019, Spanish uses 1999, but otherwise the information is all relatively the same, although only Spanish mentions the capital. Anyway, in any case, this is sort of what exists, and we can imagine that there are there are hundreds literally of languages that don't even have this much. With the current state of wiki functions, moving toward abstract Wikipedia, we can actually generate simple sentences like this. So we already have a few functions that aren't kind of doing the full natural language generation workflow you might like, but they are taking pieces of information from Wikidata, using the labels, and stitching them together to generate sentences. So this is sort of the current state of the art, that we can at least get these very simple sentences. It's a town in Kenya, it's 120 kilometers from Mombasa, this is the population, and we would of course get the most recent census. So this would be kind of a win if we feel that the most recent census is the important one to display, because as we saw, only one of these languages has that information. So for those, I don't want to dwell too much on this, because this is sort of what is still being worked out and discussed, and an area of active debate for those who are interested in natural language generation. But we're thinking about, how do you represent these facts in ways that are kind of cross-linguistically useful? So within the field of natural language generation, there are a lot of ways to do this. At the end of the day, you need some kind of representation of the semantics. So, you need to know, okay, there's something called Malindi, there's something called Kenya, and you have some predicates. You know that Malindi is a city. You know that it's located in Kenya. These are all kinds of, you might think of them as semantic frames. You might think of them in a number of different ways, but basically these are more or less atomic facts that you might want to represent in an article. Again, we're still sort of working out how to make these cross-linguistically compatible and how much can be inferred from Wikidata. Eventually, we'd want some kind of function that would say, okay, take this piece of information, take this, semantic blob, and construct it, render it in a given language. Some of these functions, again, kind of already exist. That's what we'll hopefully look at in a moment. But again, this is sort of the state of the art. Okay, so we can do live coding. I want to give people, I'm so confused. I want to give people a chance to ask questions and start discussion now, though, before we sort of jump into any kind of live coding, which may or may not take a long time. But yeah, are there any questions at the moment?
Yeah. What is the difference between this and translating, like the first paragraph?
Yeah. So that is a good question. So there's a difference between translation and generation. So translation would be if So if I see this article in Greek and I go, okay, I'm going to take this and represent all of this information in English. So translation it can of course be automated, but translation is a one-to-one relationship, meaning I go from the facts as present in one language to the facts as present in another language. Natural language generation is a one-to-many relationship, meaning that there's a single representation of the facts, and then what you use is not translation, but machinery to generate language in a number of different languages. These can both be done with very similar technologies. Like you could, if we were going to use machine learning, for example, which we're largely not, you could use transformer architectures for both of these tasks. So they are not unrelated tasks, but the important insight is that natural language generation comes from some other kind of representation that may be structured data. It may be linguistic, it may be a summary, it may be a photo. I mean, you can think of anything that could be an input to a natural language generation system, and the output is text. Does that answer the question? I want to make sure it's very clear because this is like one of the most common questions that we get.
So like you would, there would be one way to, like if there's data about the age of the person, like there's one sentence in all the articles, it will have like this person is age this, this person is age this, and like the sentence would be the same in like all the articles.
If you were to, yes, if you were to generate it using abstract Wikipedia, then yes, it would ideally contain sort of the same piece of information. Just to give a kind of a motivating example. Here. So like in theory, so we have all of these labels, right? So in Wikidata, we have all these labels for the name of the city. So Thessaloniki, Thessalonica, Thessaloniki, I mean, Salonika, it's like, generally says the same thing, but you have all this information about it. So for example, if I wanted to say, surely it has population. Yeah, so, yes. So these are like populations at a given point in time. So in theory, just using this information, we could say, okay, for Thessaloniki, what's the population? Okay, spit me out a sentence. And as long as somebody has written a function that says, here's how you represent the population of a place in X language, then in theory, we can generate that sentence for all of those languages. So yeah, it is what you said. I just want to tie it down to a concrete example. There was another raised hand over here. Or several, yeah.
So I wanted to ask about your project's dependency on lexemes. I tried to create something very similar in a Wikibase suite. We had a lot of structured data. We wanted to describe it similarly. And we were working in Finno-Ugric languages, which have a very high morphological complexity. And our biggest bottleneck was actually to find out how to build up a large enough lexeme base for this and how to maintain them. So I'm wondering how this can be done on scale, if you have any, so just for everybody to make it understand what is lexeme and why this might be an obstacle, because I think the concept itself is very simple and speaks for itself if you can make it in scale.
Do you have a favorite LID, just so I can put something relevant on the screen? Oh, here we go. We can just search for it. So yeah, so the question, if I understand correctly, is how do we scale this and make sure that we have enough lexical data? Okay, so it's 3998. So the thing I love about all these projects is which IDs you learn, like which arbitrary mappings of number to thing stick in your head. It tells you like what kind of pervert you are, I guess. Like if you know 3998 tomorrow, like you know what's wrong with you. So this is what's being talked about. Lexemes are pieces of information stored in Wikidata that deal in the linguistic aspects of a word. So in this case, where we're getting the verb dream, there's probably a separate one. Yeah, there's a separate one for noun, but basically these are all of the different things that a word can mean, so its senses, and all of the forms that it can take. So we probably have here, so in English, these are pretty easy because English is not a very morphologically rich language, but if you're working in some languages, you know, I tried to count how many forms like a verb can take in Quechua, and it's in the thousands. Like, so these things get out of hand very quickly. So the question is a good one. How do you have enough lexical data to make this work? I think there are a number of different answers to this. One of the issues that we're finding is that there isn't really a cross-linguistic sort of convention for lexical data. So even before the bottleneck of how much data is the bottleneck of how to make sure we can use the same data across languages. So that's already there. And then there's the issue of filling these things in. Some of this stuff could be done automatically, and that means that you could, instead of using just lexical data, you could augment that with wiki functions. Maybe one day we'd be able to automate the process of populating Wikidata, but that's historically been a hard sell for very good reasons. So I think that's one answer. One answer is just that we don't need to rely solely on lexical data. So like if I know that a verb is pretty regular, I can write a function to just generate the forms, and then we can use that as our kind of lexeme base. Another problem you may have run into is that our sort of Wikibase-like structure is not yet very efficient. So just importing all the lexical data into our runtime is still kind of slow. That's mostly my fault, so sorry. But that's what we're working on right now, is making that sort of more efficient, less memory hungry, all that. So basically three answers. It comes down to our system becoming more efficient, more data being populated in Wikidata, and then also just relying on wiki functions where possible when you know that you can generate the forms instead of relying solely on what's in the lexical data. Good question. Yeah?
I will continue if I can. So if I understand the concept well, for building up a natural language article by this technique, you need wiki functions, which has to be created in many languages because the grammatical system can be different. You need lexemes to use the words, the first question is that, am I correct that for every different language system you need a different wiki function because the structure of the sentence is different, so you have to create again and again for every single simple expressions or sentence structures, you have to create the wiki function again. And you need a large part of the vocabulary in the lexemes because otherwise with 10% of words you cannot create sentences. And then the question comes that if we use a large language model which can already today translate, the concept started many years ago with the fact that we have tens of millions of articles on big Wikipedias which small Wikipedias could benefit when it is translated. And today, without any effort, I mean, without this huge work which is in front of us for years, we can have this in a very short time, a very few smaller effort. So what is your opinion on this? It's three different questions.
The answers are yes, yes, and no. So the first two questions I will kind of roll into one. The current state is that most of the kind of natural language functions we've built are kind of toys. So you can see like here is and you can even see like we had like Turkish instantiating sentence, French instantiating sentence. So we're still duplicating this effort, which ideally we would not do at some point. But we can see like here's here's the function, and you can kind of see it just says, okay, you join some strings, you take the label of the thing, and then you say bir, like the Turkish indefinite article, and then you take the label for the other thing, like X is a Y. So this is, obviously not using lexical data yet. Ideally, we will get there at some point, but yeah, so those things you can handle, but it's pretty tough, and that's where you need the lexical data. So like if I wanted to, make a Turkish sentence that had a direct object, I'd be in trouble because getting the right form for the morpheme that indicates the direct object would be tough. You can do it, but it requires a lot of coding. And to your point, it's a lot of work duplicated over many over many languages. So then why not LLMs? This is a good question. So if we go back to sort of the motivating examples, Thessaloniki has pages in 129 Wikipedia editions. And so the target for this is not, English or French or German, or necessarily even Turkish. And so the target languages that we're really thinking about with Abstract Wikipedia are the languages that have fewest resources. And that means those are the languages in which LLMs absolutely do not work. Beyond that, an LLM is something you don't have control over. I mean, there are ways, right? There is research into how do you coax the LLM into doing the thing you want. But at the end of the day, an LLM is kind of runs a little contrary to the notion that this is going to be community-led. Which is not to say it would never participate in this. There are ways that we're thinking about how it could be used, how an LLM could be used for parts of it, and even how to make an LLM that would be a little bit more consensus-driven. But that's not the state of the art with LLMs. So those are the reasons. If LLMs get to the point, I mean, even the best ones I've tried, like, they don't work for Quechua, for example. Like they just don't work for a lot of languages. The best they'll do is maybe say that, oh, I think I know what language you're speaking. So that's kind of the tension there, but yeah.
I wanted to add two quick comments, including on this. I think what you left out is that maybe the strongest argument for going the Wikidata, the abstract Wikipedia way over AI, which is, if we assume the code is correct, if we got the functions right, we are guaranteed a correct text. That's a guarantee we don't get from AI. AI today, as we all know, makes mistakes. Even among, I don't know, English and French, which is one of the pairs that works best in machine translation, it can somewhat randomly negate sentences, give you literally the opposite, a Boolean opposite of a sentence. And you wouldn't know. If you don't speak the language, you wouldn't know that a sentence, one of the sentences out of, let's say, 200 sentences that were perfectly translated, but one of them has been flipped logically, and you would not know. That happens in AI today, and as you said, in smaller languages, it will happen a lot more. With this approach, which is much more labor-intensive and harder and stuff, we will get a guaranteed correct natural language output, and I think that cannot be overstated. That's a huge, huge bonus for us. When we write encyclopedias, we need them to be correct. We need people to be able to rely on that output. I think that's the biggest advantage. And the second comment is to your point about how difficult it is to get the lexical corpus. I think it's true. It's difficult. It's a lot of work, and some communities are sort of not there to do the work. But still, getting together a team, maybe even incentivizing it in some way, to produce 50,000 lexemes for a language is infinitely easier than writing an encyclopedia in that language, which may never happen. So I think that's a strong...
Both good points. I want to play as I'm probably, just speaking for myself, a bit of a hater of LLMs, but I want to note their utility. I agree with everything you just said. but I also don't want to discount the possibility that there is a role for them in these kinds of projects. Just hopefully not as like the last thing that touches a piece of information before it's served to someone. But there are ways to make them participatory. So there are, you know, ideally one day, you know, you'll be able to just say ChatGPT, like write wiki functions for me, because writing wiki functions can sometimes be a little tough. So like that would be really cool. So the other interesting thing here, and I don't necessarily put a lot of faith into this, but there are some experiments where if you have a grammar book for a language that a large language model doesn't have, and you say, hey, ChatGPT, read this grammar book and learn this new language, it can kind of do it. So there's this kind of weird transfer learning that can happen. This is like in the realm of like LLM hocus pocus, but again, I think like that's another thing you could think about, right? Is like, could we maybe like bootstrap some representation for a smaller language and then use that as some other component for this system? Okay, I feel less bad now. I think this is getting phantom inputs from like the mouse because this is just randomly twitching. Okay, I feel much less bad about the haunted slideshow, given that I think it's a hardware issue. And if anybody wants to have an LLM debate later, like we can do that at the bar, that will be fun. Yeah, what else? We have 7 more minutes, so I'm happy to take more questions or struggle through live coding, which would be, I don't know, entertaining for you all maybe? Like
I just wanted to make a very short comment on what you said, because I agree that you need a very small lexicon to make this work. So we were working with minority languages, Finno-Ugric minority languages like Liv, Setovero. We thought that this can work well with 150 words. But these languages have about 20, 30 word forms, and especially nouns are difficult in these languages, not verbs. And then what we didn't really find is good resources for volunteers, or so how to make working with Lexeme. So we don't want to have like a vocabulary of 20,000 words. I really say that this is much less effort than it seems, and I think that with 150 words you can make real impact. But even to get 150 words in the correct format, I think that would require a bit more effort in making it accessible.
Definitely agreed with that. Yeah, there is a bottleneck around how to populate Wikidata, and whether some interface, like a natural language interface, you know, built around abstract Wikipedia, could sort of be a gateway into that. These are all like kind of ideas in the air, but yeah, I agree with that. And the members of like Wikidata communities that I've spoken to are aware of this problem. That so yeah, definitely a bottleneck, definitely a thing that we're trying to work on. I think there's another hand over here.
Yeah, I wanted to say the same, that there will be disbalance between languages. For example, verbs, there are like 4 forms of a verb in English language, but in Ukrainian I estimated it's to be something like 300 forms of a verb, because it depends on grammatical gender, grammatical case, past, present, future tense, passive, active voice, present or continuous form, and so on and so on and so on. So this will create a disbalance between languages. More grammatically complicated languages will be harder to advance than simpler language. And another question is that there are queue items and there are exams. How do we link one from another? For example, there is queue item about Thessaloniki, and how do you add to that item that there are like themes about Thessaloniki?
So I was paying attention, but I wanted to show you a partial answer to your question, which is kind of, as I was saying before, I think there's a marriage here between what needs to be done with manual population of lexical data and what can be done programmatically. So I think I'm going to, so Quechua is a very highly inflected, it's an agglutinating language. So works similarly to Turkish. You can put forms on forms on forms and you can get a very long word very easily. And so these are some functions that give you, the conjugation in a given form. So this one is for the first person singular. So this is the verb like to walk. You give it the infinitive and it gives you back the verb, the form to walk. And you could imagine composing these for, agglutinating languages like this, and getting a set of functions that would then generate the whole morphological complement. This is, of course, like dangerous sometimes. So because you might have irregular verbs, you can overgenerate. There are all kinds of pitfalls with this. But again, that's where you kind of need something like the lexical data to shore it up. But just as I think this is mostly just to reassure myself, if anything, that it is in fact possible to take a sane approach to generating some of this stuff. I hope that answered your question. I'm really scared of this computer. It just keeps, it's like I'm really not touching it. I think, we have like 2 more minutes, right? Does anybody have any other questions? Just saving us from dead air.
What do you expect, how long time do we need to wait until we can see some result? I mean, not one sentence, but some articles are a language you can generate. What can we expect? Next year we can see something, or it's several years? Or
I'm like sweating. So this is live streamed, and I'm pretty sure like everybody, at least somebody on my team is watching. So they will want to kill me if I give you an answer to that question. No, I don't know. I mean, we're we are working on it right now. So we have some, so I can't give like a timeline. I will give you an answer about what we're doing right now, which is deciding on the format for this abstract content. So that's underway. That should, we should have an idea, or at least for like a first iteration of that, by the end of the calendar year at least. I mean, it's already pretty much there. So kind of what this structure here, I mean, I'm sorry, I know this looks like nonsense, but like this is, I promise this is, this is a beautiful mind idea of what abstract content and, how to render things will look like. So that is already underway. And in theory, the machinery is already there. So inside of Wiki Functions, I can, I can go and like retrieve a lexeme, right? So, so we have like, so this is a type that, is that like cutting the mic? Is that telling me I'm done? Okay. Anyway, point is I can't make a promise, but we are definitely getting to the point where this is going to be more than a toy. I don't know. I'll give you a less wishy-washy answer in the bar when I'm not on a mic. Okay, thank you, everybody. Oh.
Do you have an HDMI port?
Yes, I have.
Perfect.
Wonderful. Yay.
Testing, testing, 1, 2, 3. Hang on, let me take out my notes. Hi everyone. Thank you for joining me in the last session of today. I'm sure many of us here are feeling quite tired and exhausted from the wonderful long day of presentation and sessions. I'm going to end the day today with a very interesting discussion and presentation about Wikidata, Wikimedia's knowledge graph in the world of Gen AI. So this serves as a quick introduction to folks who are new on the topic of generative AI and large language models, LLM, and Wikidata's roles in this space. So for those of you here who are experts in this area, please bear with us, please be patient with us, because I've recognized some faces in this room who has asked me questions, what is Gen AI, you know, what does it work, how does it relate to it, even what is Wikidata. So I seek your kind patience and let's move on. So Wikidata, just a quick overview, is one of the largest Wikimedia projects. And the data on Wikidata, it is used in a lot of technology that you use every day today. And all the data in Wikidata is available under CC0 license, which means that anyone is free to use and reuse Wikidata's data. More importantly and interestingly, it is multilingual, collaborative, and a free and open knowledge graph. So when I say it's one of the largest Wikimedia projects, there's currently about 119 million items on Wikidata, and it is one of the most actively edited projects in Wikimedia, with about 25,000 active editors per month. So, Wikidata, it's a knowledge graph with a lot of structured data, and it is behind most of the Wikimedia projects, like Wikipedia, Wikimedia Commons, And besides Wikidata, you have Wikibase. Wikibase is a software that powers Wikidata, and using the same software that powers Wikidata, you can actually create your own knowledge graph. We have two products in Wikibase. One is Wikibase Cloud, where it's a hosted service for free and open projects, and the other project is called Wikibase Suite, where you host it yourself. And as you can see, I'm not going to talk into much more detail today because we have had workshops on Wikidata Wikibase over yesterday, right? Yeah, and there were more workshops over the different institutions. Long story short, if you want to have your own little mini Wikidata, download Wikibase or use Wikibase. And enjoy, what Wikidata is in your own little projects. So Wikidata is already widely adopted in various AI applications. It is the backbone of factual knowledge in many, many systems. Embedding this data in Wikidata makes it usable at scale for neural networks and large language models, and is especially valuable where factual precision and transparency matters. The use of Wikidata in AI, for example, in name entity recognition, Wikidata provides important entities, stable identifiers for information and about them. So when large language models recognize entities in text, they link Wikidata to further enhance their understanding of the entity's properties, relationship, and context. This helps to improve the accuracy when the model is asked about specific topics. Name entity disambiguation. Wikidata provides important entities and information about them. In natural language understanding tasks, it is common to encounter ambiguities about which entity is being referred to. Wikidata helps LLMs to perform this entity linking process, matching words or phrases in a text to their corresponding entities and in the knowledge base. For example, the word Mercury could refer to the planet, the chemical element, or the Roman god, and Wikidata helps these models to identify the correct entity by considering context. In this particular example we see here, jaguar, Is Jaguar an animal, or is Jaguar the brand of the automobile? In classification, entity classification, Wikidata provides relationships and hierarchies through its ontology. So when large language models need to classify entities like people, organizations, or products, Wikidata's structured data is like a gold mine for grounding these entities in specific categories. For example, if you provide the name Tesla, a large language model could use Wikidata to classify as a company, electric vehicle manufacturer, and even technological company, and Wikidata entity types, which are encoded in the form of instance of, there's a property, and the corresponding value will help the model to classify the entity correctly. Also in question answering, Wikidata acts as a background knowledge to answer new natural language questions and has been used by many digital assistants all over the world in part of their systems. Oops, sorry. It's a long day. An overview of large language models vis-a-vis knowledge graphs. Large language models learn to predict the next word. Large text corpora that are not machine understandable, requires significant amount of training data, much of which was, most of the time, sometimes, occasionally, questionably sourced. Most are not transparent or validated in their inference or training. It is hard to inspect and therefore also very hard to predict or debug. Knowledge graphs like Wikidata, for example, are explicitly modeled. Data and relationships are machine understandable. Only need to explicitly model relationship once, for example, with the entity schema extension. It's also easy to inspect and debug and can be used to validate text, such as large language model output. And the links in the graph provide knowledge, and citations to Wikidata's data provides validation. What we are seeing here today from the Wikidata team working on this project is that the large language model hype continues, right? This is something that we have all observed and can agree to. Advanced artificial intelligence is just ever more improving. LLMs are thought to progress in that direction, and this is highly influenced by financial interests. This is where most of the venture capitalists are putting the money into, to startup companies or even companies that are developing AI models. So knowledge is not part of the LLM developers, however, right? And skepticism is growing from the general public as well as the community. In some aspects, the idea that we are hitting a wall with LLM is growing traction. There's a recognition that we need to look at other, new and possibly old techniques. And a combination of such techniques and systems are expected. Pure LLMs are no longer considered sufficient. People are too easily convinced by LLMs, especially conversational interfaces, that gives you a false sense of security and trust. We are seeing the ELIZA effect in action and scale. The ELIZA effect in computer science is a tendency to project human traits, such as experience, semantic comprehension, or empathy onto, computer programs having a textured interface. It sounds very intelligent. I quote this from Wikipedia. That's not from me, yeah. So the society is still adapting, right, by LLMs and how to live or use LLMs in their day-to-day life or even work life as well. What is interesting is the point 4, is that we have observed that a social backlash is forming, right? Some people are starting to realize what the worst outcome of AI will mean for them and are starting to organize and mobilize and come together. I have been to many conferences over the past 2 years that talk about, how AI is being used in the digital humanities space, for researchers, for scholars, for librarians, in different institutions, and everyone is like, there's a pros, there's a con, what should we do about it? And this tension is there for sure. So many people are starting to realize that the real world potential and utility of LLMs is there. And most of such functions are derived, most of us may or may not know, or it does sometimes not so clear, for financial gain. So what is the role of knowledge graphs now? Knowledge graphs provide a base of knowledge. Knowledge graphs are a great source of explicitly modeled knowledge about the world, like Wikidata, that can be used to improve AI results, especially in combination with other techniques. Knowledge graphs give people agency over what is happening. Open knowledge graphs, like Wikidata, are a way for people to have an influence on the technology that is built upon them, unlike the current LLMs. Knowledge graphs validate and inform. The knowledge contained in the structure of knowledge graphs, like Wikidata, provides context by which AIs can understand more in their training data. The results of LLMs can be processed for authenticity by comparing knowledge graph information. Knowledge graphs provide greater context. Open knowledge graph, especially Wikidata, provides citations, conditions, qualification, and can inject more context into AI systems. The citations and qualifiers on Wikidata can provide an updated, validated information to the LLMs. The same information can improve validation. Gen AI versus knowledge graphs. Correctness. Knowledge graph provides explicit, accurate, and reliable human-generated content, whereas Gen AI generates responses based on statistical patterns and may hallucinate. In this example, a snapshot that we have here, when a query was being asked, who took 4th place in the women's singles event at the 1988 Winter Olympics figure skating competition, to Metalama version 3.1.7. Then we have the response is Midori Ito, right? However, if you go into Wikidata, you would see that the participant is Jill Trenery. I apologize for mispronouncing the name. Yeah, this is based on version 3.1.7. Now, if I'm not wrong, the Metalama is version 4. Yeah. Of course, they would have improved their systems, hopefully, right? Completeness. Knowledge graph retrieves lists by querying structured databases, and Gen AI, limited by recall abilities and are often unable to provide comprehensive lists. So if you make a query on Wikidata, who are all the musicians who covered a song by Bob Dylan, you will see 6,307 results. It could be more now because this was done. Yes, yeah. Every day there will be increment by at least 10 songs, right? Yeah, or 10 musicians. So you will see a full list, at least a list of the different results, as opposed to if you ask a Gen AI, for example. So freshness. Knowledge graph is easy to update to reflect the latest data, whereas Gen AI is limited to information available up to its last training date with a knowledge cutoff. So in these examples, we can see here the question asked to Metalama 3.1.7 was, when did Mark Cavendish retire? And then the response was, Mark Cavendish has not officially retired. But however, in Wikidata, we actually saw that he retired on the 10th of November 2024. If I'm not wrong, the cutoff date for the Metalama 3.1.7 was actually in 2022. Yeah, so there's this freshness issue that we see. Transparency, right? Knowledge graph allows users to trace and verify the source of information. You put your references, you have notability, criteria, whereas for Gen AI, the functions as a black box, which was actually mentioned in another lecture just now. with unclear and non-transparent processes, unable to inspect and or debug. Good luck trying to find out, what are sources used by the different, AI tools, like, ChatGPT, for example. Generation, however, knowledge graph is not inherently generative, but can derive new knowledge through ontology. Whereas for Gen AI, they're designed to create customized, individualized content, adapting responses to user needs. Well, if you ask, hello, then the Gen AI will respond to you nicely in a very friendly way that makes you feel like, oh, wow, I'm being heard, right? It's interactive. Yeah. Whereas for knowledge graph, if you put a sparkle, hello, probably, yeah. Not so fun responses. I mean, that is if you take the effort to learn Sparkle. Yeah. Usability, right? Knowledge graph can be complex to use, requiring knowledge of Sparkle for information retrieval. Look at this Sparkle query service there, and Gen AI is user-friendly and capable of responding to natural language queries. Don't feel sad. I have something to show everyone later at the end of this presentation, a sneak preview, of what we are doing, so you can see where we are going. Yeah. Give instructions. Typically, knowledge graph lacks the data needed to provide instructions, where Gen AI can easily generate output to instructional queries. You can ask for a recipe. You can ask, oh, how do I tie a knot? You can ask question like, make me, what's the recipe of Greek salad, for example, since we are in Greece. Yeah. So the most powerful system, however, will combine both, using knowledge graph to ground the AI outputs, to validate claims or to retrieve accurate facts, and use Gen AI to query, summarize, or interpret knowledge graphs in a natural language. For example, a chatbot that pulls verified facts from Wikidata can be used to answer questions fluently and accurately. So, as a summary, this is not the end of the presentation. The summary of that particular section is that Gen AIs may excel at language generation and generalization from patterns, but they can struggle with factual accuracy and traceability, whereas knowledge graphs are designed for factual precision, semantic relationships, and able to explain, but they lack the creative, generative capabilities of Gen AI. So what does the future look like? The most powerful systems, we think, in the future will combine a bit of both. Use knowledge graph to ground the outputs, as well as use Gen AI to query, summarize, interpret knowledge graph in a natural language way. Now, this is the fun part about what we're doing at Wikidata, the Wikidata vector database. So what is a vector database? Let me give you a quick crash course here. I'm not an expert in this, and there's no reason to dwell too much in this, at this session, but just for those of us who are hearing this for the first time, a vector database is a database that stores data as vector representations, and it enables natural language search capabilities. For example, if you ask who is Maya Angelou's spouse, the vector database from Wikidata will make a query to the vector database, and then it will come back with a return of the relevant items, as you can see here. You can ask various questions like, what is the American poet and activist? So a vector is a representation of data transformed into numerical values. These numbers are interpretable and meaningful to machines. So the vectors allow for mathematical operations, facilitating analysis and comparison of data. For all of us here who are not technically trained, this is a quick image. King is represented by this set of numerical numbers, minus away men, represented by another set of numerical numbers, plus women, which is another set of numerical numbers, equals a queen, right? And this is how the machine understands this in this way, and not king, man as words in itself, or as items or entities in themselves. So the vectors enable clustering by grouping data based on their contextual meanings, right? For example, you have kiwi as a fruit, kiwi as an animal, orange as a fruit and orange as a color. And these vectors can also represent different queries to match them with semantically similar Wikidata entities, right? For example, you can ask the question which animals can be pets, and then this query is embedded into the vector database, and then it's mapped into the vector space. And now we can see that the Wikidata knowledge graph on the left-hand side is here. We are currently in the process of transforming the knowledge graph Wikidata entities into vectors, which is what we are working on, and then to create a vector, Wikidata vector database, that would then enable users or even different Gen AI tools or projects, open source of course, out there, to query the vector database and then come out with a return of an item of Wikidata. So in this example here, you see, it transforms each item into a text representation, right? And then it embeds the text into a vector representation and then stores the vectors into the database. If you see Gina AI and DataStax, these are the partners that we are working with to build this vector database. And of course, the beauty of Wikidata and all Wikimedia projects, it is multilingual, so we shouldn't forget that, we shouldn't only make queries in the English language, but also have the ability to make queries in multiple languages as well. And this is something that we're working with. The partners that we are working with, Gina AI can support up to 100 over languages, and we are trying to see how we can work closer together with them on this. So, as you can see here, in different languages, it stores only the German and French, for example, into the vector database. And then when you query the writer of I know why the cage bird sings, and query it in English, and then it can return an item from Wikidata item. I can be a bit ambitious and do a demo later if everybody wants. Yeah. So the use cases of vector databases, if you ask us, why do we invest this kind of resources into building something like this, right? It's because of retrieval augmented generation. I'm sure all of you who goes to different conferences, events, or even team meetings in your various workspaces, you will hear this term called RAG, R-A-G, RAG, or what is RAG? So RAG means actually retrieval augmented generation. So by integrating the Gen AI with external databases to reference accurate and up-to-date data while generating an output. So the Wikidata vector database, first you make a query, you go into that, and then you come out with the entities QIDs. And this output is actually collected from the QIDs from Wikidata, and then you would pull it out again as a response. So, but what is interesting is the response come out to you is the spouse of Maya Angelou is Paul DeFeo, right? And not just that just an item in itself. So for RAG, it reduces hallucinations, retrieves reference information and minimizing error. It reduces misinformation, allows users to verify information and trace sources for accountability, ensures freshness, Gen AI references constantly updated information from Wikidata, and amplifies underrepresented knowledge, which is very, very important in what we do here, Contributions to Wikidata have a stronger impact on Gen AI, preserving diversity against dormant sources. In name entity disambiguation, this process of linking a name entity in its text to correct reference in Wikidata. As you can see, man playing flute, engraving created by John Smith in this particular period of time, and then you can see there's so many John Smith in Wikidata. But if you query the vector database, you will be able to pull out, what is the man playing flute. Sorry, man playing flute. Oh my God, it's a long day, sorry. Yeah. So the process is that we embed the text into a vector, and then it goes into the vector database, and we can see the respective or relevant John Smith item in the response. These slides are shared on Commons, so when you have time, you want to take a closer look at it, feel free to look at it. I'm not going to, I think most people will fall asleep, if we dwell too much on this, but you get the idea, right? Also for the rec, also for classification, the task of assigning predefined categories or labels to a given text based on its context. Right, in news article, for example, it says NASA successfully lands a rover on Mars to explore potential signs of life, and then you can see the different classification that's being assigned here in what is relevant to, and we can map this topic into science as an entity in Wikidata. Now, this is the final part, which is actually quite interesting. I'm not sure if I should do a demo, but let's see. Live demo is always challenging, right? Good news is, what we feel is that developers especially open source developers for Gen AI, they have a lot of frustrations. They have hallucinated facts, missing sources, training data. These are all the frustrations that they have. And the fix that we are proposing is the Wikidata embedding project. And the Wikidata embedding project is to enable the use and reuse of Wikidata's data more easily. We will officially announce and launch this on 1st of October, which is a few days from now. So keep it to yourself until you see the official announcement. But since you're also kind, come to this room, and join me in this last session of the day, I will give you some sneak preview. So the goals of what we want to achieve is to create an open source vector database on top of Wikidata, so that we can improve accessibility by enabling semantic search on Wikidata. We want to encourage, more importantly, open source AI and machine learning community to build AI projects around Wikidata. The current landscape is that the resources that is needed to build Gen AI tools are monopolized or clustered by several big tech companies which receive a lot of funding. And a lot of open source projects, they are also interested to come into this space, and they also want to find a way to reuse Wikidata's data for their project, but because we are not vectorized, the obstacles to do so becomes higher and the friction becomes small. And our goal is to vectorize our database so that we can enable these open source projects to build on top of Wikidata. So if you're interested, not yet. So this is a sneak preview of the user interface that we have. Currently, am I allowed to announce this maybe? So currently we are supporting 3 languages, English, French, and Arabic. This is something that we are working on, and this is the interface. If you type what's the capital of Greece, you come up with a result instead of just having a Sparkle query, trying to find out property values and stuff like that. And then you will see a result. I purposely took a screenshot of this in Arabic so that you have a sense of how we're working with. If you are interested to test a prototype, please check out the web page for more information and join us in the discussion on the project page. Or you can send an email to my colleague who is the expert in this project, Philip. He will be able to address your queries. Thank you. Are you interested to see a quick demo? Yeah? Okay. Still live stream, is it? Okay, I hope nobody will be upset with me. All right, as you can see here, I was doing this just now, and I took a screenshot, and I tried it in French language as well, and then you would, that's not fun, right? Let's try let's try in English first, all right? Then let's see the results. Fingers crossed. Or in German, we say push thumbs. Awkward silence. Let me try to sing a song to fill the gap here. Yeah. So this is the embedding project that we have. And as you can see here, you can select whether you want to have the results in all languages, Arabic, English, or French. We will continue to expand and work on, including more languages, and ideally hope that we'll be able to do this. There's only a couple of people in the team working on this, so please bear with us. Yeah. Hello. Yeah. Don't worry, it's coming. I'm confident. Ta-da! Okay, then you have Regal, right? Woohoo! Whew. If you click on this result here, it will bring you to the respective Wikidata item in Wikidata. Let's try something a bit. No, languages do people in Greece speak. Let's try something a bit more complex. Again, fingers crossed. I think we can turn off this live stream right now in case I messed up, then I'll lose my job the next day. Just kidding. Disclaimer, yeah, this is something that we're just trying out now to show everyone a quick demo. Because since we're going to announce this on 1st of October, and we are right in the middle, we're just right now, CE conference is just right before that. I thought that it's nice for me to give you a sneak preview, right? And instead of waiting until next year, when the next CE conference, and to share with everyone. I will try a different language later, just to get a sense of it. Okay, so we have a list of different languages. It's not the kind of results that you wish to get from a ChatGPT, for sure. But it's a demo to show you that, okay, it pulls out certain results that may be interesting for the user who is making a query, and then the user can just go into different items to see for him, her, or themselves. There's also the opportunity for other open source Gen AI projects to build on top of this and to work on this, right? Because we already have a vector database, this is just something for you to have a sneak preview. Let's be a bit ambitious and try it in French, shall we? I can't speak French, but let's just see. Yeah. I know, live demos, right? Yeah, can be quite challenging, yeah. So, as you can see, the small little fine print here, this tool is in early testing. Yeah, we have a disclaimer there. But it doesn't mean that you're not welcome to try and test it out. So I think after 1st October, when we publicly announce it, then everyone can go on to this project and have a feel of it and test it out yourself. Give us the feedback, please, because we really need your feedback in order for us to make this project a bit more robust so that we can support the open source community. Yeah. Otherwise, we will never be able to level the playing field, right? I think with a colleague earlier on in the Wikipedia and AI talk was mentioning wonderful news that, we need to find ways to, oh wow, the results are out, you see? This is in French. Okay, so yeah. So, is that okay? Are you satisfied with this? Thank you. Thank you very much. Yeah, thank you. Yeah. Oops. Okay. Any question? Otherwise, I'm also happy to take questions at a coffee bar or something. Yes, Camilo.
So thanks very much for the presentation, and all very interesting, especially the last part about like these new ways of making Wikidata more usable for AI developers. I had a question, in fact, on the first part, like the easy one, that is like AI uses Wikidata, because I think that like we know, at least in this room, we know that the general public knows pretty well Wikipedia, but still a lot, like the great majority of persons ignore completely Wikidata. And also when we go not to the general public, but let's say to GLAM institution or to universities and present Wikidata, it's generally very well appreciated, but then like a lot of people don't fully understand the importance of collecting data. Collecting data is something that for a lot of people is not really attractive, also because they don't understand why we collect the data. So I think that if we go and say that we collect the data also because this influences what AI tools then say in their answers, I think that this can ring a bell to a lot of institutions and universities to understand that having data, more quality data on Wikidata could be important. So my question is like exactly which is the evidence that we have to demonstrate that AI presently is using Wikidata? Is this something that is documented by AI developers that publish documents saying we use Wikidata? Is something that AI developers say to us informally but there is nothing written? Is something that we find out empirically posing answers to the AI, and we notice that in like the great majority of cases the answer coincides with what Wikidata says? So which is exactly the evidence that we have to prove that as of now Wikidata is being used by AI? Because I think that presenting this evidence to institutions of various kinds can make a strong case to convince these institutions to engage with Wikidata. This is the question. Thank you.
I agree with you. Firstly, to address the first part of your comment, I do not think that talking to GLAM institutions and telling them that AI uses Wikidata is a convincing argument for them to share their knowledge into Wikidata, because although we know for sure that the trend of Gen AI is here to stay and it's only going to be more progressive, we have over the years, of course, we have seen technologies, concepts that come up and down, like cryptocurrency, wow, metaverse, wow, and then after a while the hype just goes down. But to a certain extent, Gen AI seems to be more and more embedded into the workflow of many tools. I mean, like it or not, even your mobile phone now, right? Everyone's trying to incorporate AI into their systems, right? Why? I don't need AI in Microsoft Office. I don't need AI in my mobile phone, right? Do I need AI in my photo app to tell me, how to take a better picture or something like that? So, and these are so indispensable, we can't even choose not to have this AI into our day-to-day lives. And I think many people are realizing that. I mean, my mom, she's more than 70 years old, and she's also realizing that, right? My kid, who is 12 years old, is like, ooh, wow, AI is everywhere, yeah. So something that is quite intrusive, I would say, right? Because I can't choose not to want it. It's going to be a fact that we have to learn to live with. And as you know, you're an expert in Wikidata. We never know who reuses the data on Wikidata, right? The best way I can answer.
How do we demonstrate that AI is using Wikidata? Can we demonstrate it, or can we just base like a strong suspect without like proof to that?
Okay, the best way I can do, which I really don't like to do it, is to ask ChatGPT. Does AI uses Wikidata, right? This is an AI in itself, and the response says you know, whatever, it gives you the best response because the AI will tell you whether they are reusing Wikidata or using Wikidata. Okay, let's just give a simple prompt. Sorry, my is using. What is my word? Is this a fair way of making a prompt? Yeah, it's short and sweet and simple. It's not the best way, but you know, let's see. There you go. I mean, I don't have to tell you whether AI is using Wikidata, right? Ask the AIs themselves. Because Wikidata, like all Wikimedia projects, we do not track the users, we respect. Yeah, we respect anonymity. We encourage users to reuse Wikidata's data without attribution, it's CC0. And yeah, if we ask the AI themselves, are you using Wikidata? They will say can and often use Wikidata. I think given this response, probably we can sufficiently say that, okay, they are, and we can, you know, assume that they do as evidence. Yes, is it satisfying? I don't really like to use this as an example, but probably it's the best way to answer your question. Ask the AI themselves. I see two hands here.
I just wanted to connect to the previous question and remark. I was able to convince GLAM institutions and also rights management organizations to give plenty of music and music composer data to Wikidata. And the argument was very simple. We showed that in Slovakia, the Spotify recommender engine was not recommending Slovak music for Slovak people. Why? Because it didn't have access to train the data on. So we started to inject data and it solves the problem. So I really think that for getting to reliable resources on Wikidata, this is an extremely convincing argument that AI uses it. AI needs reliable sources. We are reliable curated sources. So I just really want to say that this argument, at least in my case, is proven to work.
And yeah, just to respond to that before we move to the next question, could be another topic. And like I mentioned to you earlier on, I do not use this as a reason to try to convince GLAM institutions to share their knowledge into Wikidata, because that's not why we should do it, right? You know, preservation of knowledge, knowledge equity, you know, we want to make sure that knowledge, culture, heritage knowledge from underrepresented communities and institutions should always be the first and main reasons why we want to do this. Yeah, but knowing, thank you, that AI tools are using Wikidata's data will encourage us to ensure that the quality of data on Wikidata has to be as best, as good, as updated as possible, because it is our responsibility, you know, as knowledge workers, as Wikidata, as Wikimedians, contributors, you know, as people who want to promote free and fair knowledge, to make this as accessible and as updated as possible, right? And this is why we do what we do, right? You spend, what, 12 years of your life doing this, contributing, amazing effort, you know, Camilo. 8 million edits on Wikidata. This is why we do what we do, and not because AI is using, so therefore, oh, let's all do it now. Yeah, because,
I think it's not the only reason, it's one of the reasons that can convince the institutions.
For institutions, I mean, we have representatives from institutions here, yeah. There's different reasons why they do that, yeah.
Could be one.
But, yeah. But what I always try to pitch to the institutions is that we know that AI is trying to use or has been using Wikidata's data, reusing Wikidata's data, and in your workplace, increasingly, you are seeing a lot of AI tools coming into your work systems, whether you like it or not, right? But if you know that, then please, if you are in the position of authority, please get your AI vendors to use Wikidata's data in the tools that they're building. If they are not, if you can choose not to work with them, not to work with them. Choose to work with open source AI vendors as possible, right, as much as possible, those who promote the similar values that we all have, and also choose to work with vendors who can be transparent about the sources, of where they get their training model from. I think these are steps that we can do as institutions. I mean, of course, there are GLAM experts here in this room. I'm definitely not one of the experts here, but I can suggest, and we can probably come up with a discussion and brainstorm how we can do this together. Yeah. So, thank you. Do you have a question?
Yeah, just a quick one. So when you did the search with the same query in English, you requested the results in English and then in French. It's interesting that the results were different. So
Oh, really?
I would have naively expected
Sorry.
I would have naively expected the results to be essentially the same, just labeled, taking the labels from Wikidata. So I want to just check my understanding. Is this translating the query to French and then querying, or is the vector database built off of some natural language representation to make the embeddings? Because I would have expected it just to be the structured data that builds the embedding. So I guess I'm wondering what accounts for the asymmetry.
I am honest with you, I do not know the workings behind this, yeah? But what I'm really fascinated is, I can make a query in English, and I want to have the result in French, and it comes out in French. I can make a query in English, because this is the only language I can make a query now. If I can make a query in Vietnamese, German, or even Malay, I'll probably be able to make that, but I can't because it's English now. And if I choose to have the result in French, you come out in French, the French, yeah. So I think this is something that we overlook, but this is something special. But I can't answer your question. My colleague can probably best address this. Do you see the email right to him, Philip? Yeah. Yeah. So I don't have to make the query in French just because, I want the results to be in French. But if you click on the results, it brings you the Wikidata item, and of course I see it in English because my interface is in English, right? But this is something that is quite special and unique. We built this for some time. So it is in a very, very small team, I can tell you. It's only 2 people, working on it. So thank you. Any other question? Otherwise, I think it's time for us to stop, right? Thank you very much. Thank you for your attention. I hope the last session has been meaningful and insightful for each and every one of you, and quite exciting as well. So if there's any questions you want to follow up, feel free to come up to me. We can have a chat. Yeah, happy to share more.